available to those of skill, as it's known in the patent law. We had put on deposit at the American Type Culture Collection. But our aim in filing this patent application was not just to obtain a patent on the 5T3 cell line and the monoclonal antibodies coming out of the 5T3 cell line, but a whole large family of any IgM monoclonal antibodies of high affinity that bound the hepatitis B surface antigen. So we went beyond what is known in patent law as a species, meaning just the 5T3 monoclonal antibodies, but we wanted to have a genus of all monoclonal antibodies of high affinity. And there's a big world of difference between trying to patent a unique monoclonal antibody that is particularly good, like 5T3, or a whole family of antibodies, a genus, as we say in law. So we filed this patent application, and we quickly run into trouble. It was filed in 1980, and it didn't issue until about 1989. And the reason was the Patent Office had no idea how to decide how broad the scope of this patent ought to be. We had deposited one. The patent examiner kept saying, well, you deposited one, and you have therefore, as we say in law, enabled one, but I'm not going to give you all the other ones. And all the other ones means thousands and thousands and thousands, including IgM monoclonal antibodies that had not yet been made or invented. And I argued that we had made, that Jack and Zurawski and Shoemaker had made a very broad invention, and it was not just limited to 5T3, and a patent to just 5T3 was not going to be very useful because everybody else was going to be able to make these IgM monoclonal antibodies using Jack's methodology and avoid the patent if all it was limited to 5T3. Well, the examiner dug in her heels, Margaret Moscovitz, I remember her, and she said, no, take me to appeal. So we ended up going to the Board of Appeals at the Patent Office. The Board of Appeals affirmed the examiner, as they are prone to do. And so we went from the Board of Appeals to the Court of Appeals. And the Court of Appeals is known as the Court of Appeals for the Federal Circuit, the CAFC. And eventually, by 1989, the patent issues, but not before, we had a complicated, lengthy appeal, including an oral hearing at the Court of Appeals for the Federal Circuit, where the Court of Appeals for the Federal Circuit agreed with Jack and Zurawski and Shoemaker that they had enabled those of skill to make more than just the 5T3, that anybody that reproduced the methodology that Wands had described in his patent application would be able to make another monoclonal IgM, another monoclonal IgM, another one, and another one, another one, and agreed with us that Wands et al. Were entitled to obtain a broad genus claim. This is the issued patent, immunoassay utilizing monoclonal high-affinity IgM antibodies, filed in 1980, issued November 7 of 1989, long expired, but much more important than the patent. Let's see if I have gotten. Much more important than the patent is the decision itself. And the decision is called, oops, I keep going, In re Ones. And you can see the decision on the right. In re Ones, Vince Zarowski and Hubert Shoemaker, U.S. Court of Appeals, Federal Circuit, September 30, 1988. This decision, and I am not at all doubtful to say, is perhaps one of the most important decisions in the patent law of the United States, especially in the area of enablement of broad, generic claims to all kinds of things, not just monoclonal antibodies. If you ask a patent lawyer today if he has ever heard of Jack Wands, he may not have heard of Jack Wands, but he has certainly heard of In re Wands. And since this decision came down, I have called Jack In re. And In re Wands is in the area of biotechnology patent law, perhaps as important as, say, Roe v. Wade has been in the area of abortion rights, or Citizen United is in the area of funding for political causes, or Miranda is in the area of criminal law. It is one of the most cited cases in the patent law of enablement. And it is based on an analysis that the court made of what it takes to analyze how much patent protection somebody is entitled to with maybe having made 1, 2, 3 different species, and yet asking the patent office and the courts to give them a broad genus of all possible species without naming anyone. And there are 8 very specific factors that the courts are using ever since this decision. And believe it or not, they are called the 8 Wands factors. And the Wands factors are listed in this slide, and it's a bit of legalese, but they have to do with how much experimentation is necessary to get the next species and the next species and the next species. How much direction is in the patent application? Do you have any working examples? What is the nature of the invention? Is it in biology? Is it in organic chemistry? Is it in mechanical engineering? Is it in electronics? Is it in AI? What is the state of the art? What are the publications? What does the world know about this before the filing? What is the skill? Is the art predictable or unpredictable? And how broad are the claims? These are known as the Wands factors. And the courts are constantly today talking about Wands factor 2, Wands factor 6, Wands factor 8. His name is forever associated with this case and with these 8 Wands factors. There are, since that decision in 1988, about 1,300 citations to In re Wands in the federal courts. The name Wands is bandied about by the courts every time they analyze enablement and scope of a patent. It all started with an appeal from the Wands patent application from the Mass General to the Court of Appeals. So certainly any patent applications that are filed in the patent office that get rejected and get appealed to the court, as we call it in law, ex parte rejections, because it's just between the applicant and the examiner, gets analyzed under the Wands factors. And I'm giving you just 2 examples of these thousands of citations to In re Wands. In re Vike in 1991, the case dealt with a very large family of genetically engineered blue-green algae. The court said, the specification must teach those in the art to make and use the invention without undue experimentation, citing INRE Once. INRE Goodman was a case dealing with genetically engineered plant cells, and they cited INRE Once. In 1999, so we're talking 11 years later, a case dealing with antisense technology went up to the Court of Appeals, but it came from litigation between Enzo, Biochem, and Calgene. And the argument there was, well, this was only an analysis that should be limited to ex parte prosecution. We should not bring in the Once factors into inter partes litigation between two parties. It's only between the patent office and the applicant. And the Court of Appeals said, no. The Once factors are very good. They're indeed applicable to all inter partes litigation. And the district court concluded that you needed to look at them. And when applied from the proper temporal perspective, they're a very useful methodology for determining enablement, both in ex parte and inter partes. So the Once factors and the Once analyses are applied whether you are coming from the patent office or litigating against someone else. And the Once factors have now been expanded to determine the scope of patents, not just in biotechnology. Certainly in biotechnology, it's where they are mostly used. In Ilan v. Mayo, 2003, the case dealt with genetically engineered mice, and INRE Once was cited. In Alcon v. Barr in 2014, so we're talking 10 years ago, the case dealt with pharmaceutical compositions, and INRE Once was cited. And in 2007, the patents dealt with crash sensors for cars. And the question was, should they be able to get more than the one identified crash sensor, or can they get all crash sensors? And sure enough, the court applied INRE Once to crash sensors. If Jack only knew how far the Once factors have gone, he would get a kick. Actually, he did know, because I talked to him very often. And as Once and INRE Once became more and more used, I used to call him and say, you know, your famous factors are now applicable to crash sensors for cars, believe it or not. And he would laugh, and I would call him INRE. Hello, INRE, how are you? Before I tell you about this, I have written a book on the history of intellectual property and biotechnology, which is coming out next year in 2024. It's in production right now. It's called Patenting Life, and it will come out probably towards the end of the summer of 2024. And I have a whole chapter on Jack Once and on his case, and how important the case was, not just for me as a young lawyer at the time, but for the jurisprudence of patent law in the United States. And Jack got very excited. I sent him the chapter. He worked with me to get it just right, corrected my mistakes, and make sure that I was telling it the way it was. And he was very excited. He always used to say to me when I talked to him that that he had, through his work and his case, helped get my 3 daughters through college. And I should thank him for it. And I certainly did. I would certainly do that. And he was very excited that the case was, that the book was coming out. He wanted to buy 10 copies already ahead of time. And then broke my heart to find out that he had passed away. I was truly sad and heartbroken, and I am still now as I'm talking about it, because I love the man. So I'm going to dedicate the book to him. And the dedication is to the memory of Professor Jack Wans, long a dear colleague who sadly passed away before seeing the publication of his book. And I will think about him when the book gets published, late 24. But before I leave you, let me tell you of an anecdote that will give a little more maybe humor to my experience with Jack. And I think it sort of mirrors the experiences that all of you who knew him have described. At one point in the middle 80s, Jack and I and Marvin Guthrie flew to Paris to meet with Dominique Velay. I am so sorry, Dominique, that I am not in Boston today. I am in Miami for a family wedding, and I couldn't be there. Otherwise, I would have shaken your hand after 40 years. I'm sure you remember that we were in Paris in the mid-80s, and we were discussing intellectual property and its application to biology. And we were discussing this at a very high philosophical level, as you can only do in France. The analysis goes way beyond law. It was a philosophical analysis as to whether one ought to or not ought to patent living beings and how biotechnology was going to change, and whether we would see other companies being formed and what the commercialization of biology would mean to the world. And I remember having several very in-depth discussions about law, commerce, philosophy, metaphysics, as you can only do in Paris, as I say. And then after all of that, and a wonderful dinner at your relative's home, Dominique, Jack said, well, now that we're all done with this, he produces 3 tickets to go to the Crazy Horse Saloon. And he said, come on, now we're done with all this patent law, all this monoclonal antibody stuff. I'm inviting. And Jack Wans took me to my first visit to the Crazy Horse Saloon. I will never, ever forget it. So with that wonderful memory, I thank you again for inviting me and for having given you a chance to see Jack's impact in the world of law way beyond what you may have heard about his already well-known impactful life in the world of science. And he will forever, for me, be in Ray. It was a pleasure getting to know you in Ray. Thank you.
Thank you, Jorge. Who knew? Who knew? So, go ahead, the next video. Any questions or anything for Jorge? I think we heard lots about patent law, Jorge. We learned a lot about patent law now. We really appreciate that. Thank you very much. Okay, we're going to hear a little bit more from Ingrid shortly. You want to stay?
I'll stay. I'll stay for a few minutes.
Okay. All right, cool. Play the video from Dr. Bai. The next video is from Dr. Bai. He was a postdoc with us about 2018, 2019 from China.
It was the worst day for me of July 19, 2023, because I was silent student of the passing of Dr. Wang. It was very, very difficult for me to accept the fact that my respected mentor, Dr. Wang, had that chance. Just a few weeks ago, Teacher Dong and I was discussing whether I could invite Dr. Wang's party to watch the vaccination show. Unfortunately, everything suddenly became impossible within a young separation. Dr. Wang was highly privileged and told me a lot of knowledge of digestive disease. I admire his exceptional intellectual qualities and experience. I learned a lot of righteous principles about being a good man from him. I will strive to improve my skills, love every patient, and pass on your spirit as you have to me. With a Chinese saying, you will always live in my heart. Dr. Wang, may you rest in peace.
Okay. Well, Jack's sort of association with patents didn't end with that one. They went on and on and on and on and on. And he was very, very lucky to have Ingrid Beatty from Minson Levin, I believe, right? Be the one that sort of like navigated all this for him. And so she has a few recollections of her own that she's going to share with us. I don't think you need that, but I'll.
No, don't. Ralph, which? Okay.
Right, there you go. Go on to the that's he has the side representation. There we go.
Oh, there we go. Okay. Yes, hi, my name is Ingrid Beatty, and unlike Jorge, who is also legendary, by the way, for that case, I don't litigate. I prosecute or write patents, and in collaboration with the inventors, and prosecute them to procure patent protection. So Rolf kind of went through the scope of Jack's research interests, and this is a brief sampling of the IP scope. And you know, as was discussed before, it's incredibly vast. I started working with Jack in probably 1998, 1999, so almost 25 years. And the first one on that list is we filed it, I think, in 1999. It was absolutely extensive. From that one patent application, we ended up with 6 patents, 2 regarding diagnosis of liver disease, 2 for treatment, and 2, I don't know where, oh, there's Ralph, on monoclonal antibodies that I'm sure Ralph had a lot to do with. And speaking of diligence, and I know Suzanne, I saw it in great capital letters in your title. I just want an example of Jack's diligence and thoroughness. It was an enormous patent application, lots of claims, lots of different categories of claiming. And as you may have noticed on my profile there, I had a snapshot of one of the first patents that issued, and it lists the inventors. And Dr. Gambari, who's I don't think here today, is listed on that one particular application because he had something to do with, I think it was a diagnostic. The other 5 each have a slightly different inventorship. Rolf is on the monoclonal antibodies. Suzanne and Dr. Ince is on the therapeutics and diagnostics. And my point is, each particular claim is what drives the inventorship. And Jack and I would go through this for every single patent application to make sure we got it right. In other words, authorship on a paper does not mean inventorship on a patent application. The inventorship is driven by the specific claims. And we would go through every single claim and the contributions that were made. In other words, who did what when, and linked a particular individual or researcher participant in the activity that led to the invention to a claim. So if there was ever a dispute, it was incredibly well documented, and we can prove, and here's the reason why, who did what when. So that was the first application. I'll talk about that a little bit more next. I didn't know, by the way, that Jack named his mice. But he also named his patent applications, and he had pet names for them. And of course, as some of you know, the first one was Haha, which everybody loved because it was, I mean, you had a smile. You said that, and sort of an loose interpretation or poetic license, I guess, to HAAH, our favorite antigen, right? The last one, well, actually, let me flip the slide here. Okay, there you go. There is the acronym of the favorite antigen, and we would call it HAHA. The last one on the list is his pet name was the mother of all patents. I see, I see Suzanne nodding her head, and I actually, and I would get these projects. The phone would ring either from Peggy McGill, who is the director of research, and she handled the patent stuff, or toward the end, as I became more friendly with Jack, the phone would ring and it would be Jack, and he'd be all excited about a particular finding, and then we would have to hatch a plan to find a way to patent it. So 2018, the phone rings, and it's Jack on the other end of the line. Ingrid, drop everything. I have got the mother of all patents. Do tell. And not surprisingly, it applies to many different cancers, but of course, with the favorite antigen, the focus was on hepatocellular carcinoma. So, and I'm just going to read a portion of the patent application itself, the language of which came from our discussions and some of the invention disclosure. I'm sure we wordsmithed the text, but this came directly from the patent application. Oops, wrong glasses. The invention provides a solution to the long-standing problem of cancer therapy by providing a method for achieving unanticipated and dramatic inhibition of tumor development, growth, relapse, and progression, as well as metastatic spread to other sites and organs in the body. The mother of all patents. And you can, I mean, I'm sure you can see Jack's personality come through in that one sentence. Now, the provisional was filed in 2018. The PCT, which is sort of a clearinghouse to go all over the rest of the world, was in 2019. Then about a year, 6 months later, you pick particular countries in which to file the application: US, Europe, Japan, China, wherever. And so it hasn't been examined yet. It hasn't been picked up yet for examination. It's just starting in the United States. I hope and pray and feel confident that it will make its mark, and it will indeed be the mother of all patents. I'm going to be brief here, but I'm going to just tell some, a few more stories. Jack really did check all the boxes more than any other inventor that I've worked with, and he was an active partner, and that's not always the case. Sometimes, I receive a manuscript and morph it into a patent application for the goal of getting commercial protection for elements of that invention. With Jack, it was a different story. I mean, he was hands-on. We would have discussions, back and forth, wordsmithing. I mean, it was exciting. It was so much fun. And he was just passionate about this stuff, and just intense and diligent about this stuff. And that is the reason for his success. I mean, there's no, there's no disputing that. Inventorship, I briefly talked about the inventorship. All patent attorneys should be that diligent, but it doesn't always happen. We would do it routinely, and we would ascribe the responsibility for various pieces of data so as to link individual contributions and research results to what is eventually claimed. Because as I mentioned before, being an inventor is not synonymous with being an author on a paper. And that has actually come into play. We have encountered, I wouldn't perhaps not go so far as to say disputes, but in one occasion it was. We have certainly found, I have found situations where I've been searching around looking for competing intellectual property or patents, and found a patent that looked to me that Jack should be an inventor on, but he wasn't listed as an inventor. And we've had situations where I've had to call up the institution and say, hey, we found, patent number thus and such, and we recognize some of the data and some of the conclusions, and we believe that Dr. Wands should have been listed as an inventor on claim X or Y or Z, and have had interactions, and both sides provide proof. And of course, we had very good diligence and much detail, and in at least 2 separate occasions have had Jack added to the patent as being an inventor. So again, it was fun, but it was always important, and, absolutely his attention to detail and our working together to make it a comprehensive project from every different direction for these patents was extremely important. And the other thing is licensing strategies. He was very active in Panacea was the recipient, took a license, an exclusive license to much of the HaHa work, as the original patent and many subsequent follow-on applications and patents on that molecule. But also, we did a licensing deal with, and this stemmed from some collaborations he was doing with Chinese entities. I think this was the first licensing deal done with a Chinese military hospital. In other words, I collaborate with a corporate licensing partner of mine on that. We had no example. And the Chinese were, they had a certain way of doing things that was very different from licensing agreements here in the United States. We got it done. There was an agreement. It was remarkably rewarding. And again, he had a great hand in facilitating that, and helping us craft the language and putting us in touch with people who would make this licensing agreement work. And then finally, to echo what Jorge said, in Wands, I can't stress the importance. It changed the patent landscape. It is that important a case. I mean, it literally revolutionized the standard for determining what is enabled. And by enabled, that term in the patent world means how can you make, by what's written in the patent application, can you make and use that invention that's articulated by the claim. So it really, all of those, and I taught those 8 Wands factors. And each one of them, if the patent examiner rejects your claim and says, it's not enabled, there's not enough detail here, nobody could pick this up and reproduce it. If you check the boxes and explain to the patent examiner that we have done all of these 8 Wands factors, you will prevail. It's that simple. It is the art standard now. And I'm so proud that I know Jack Wands. And in my law firm, when I assign cases and Jack Wands is listed on the list of inventors, the associate will say, "Is that Henry Wands?" Wands, I'm like, "That's the one." Wow. So it's just been so enjoyable. Oops, what do I do now? Oh, there we go. There we go. Oops. So in conclusion, he was the consummate inventor. He did check all the boxes. He was involved in every aspect of it. And he was so passionate and so exciting to work with. Absolutely unforgettable. And he means a lot to me. He leaves a great big hole.
We have another video message. This from two people who were both research associates. They did their postdoctoral fellowships at the Liver Research Center in Providence, Rhode Island, and went on to become quite well established in Japan.
Hi, I'm Yoshi from Japan. I will meet Dr. Wang. I really feel honored to have had the opportunity to work with him. The 2 years I spent with him and all the development at the Liver Center were the most enjoyable and productive of my life. I have nothing but gratitude towards him. Very thankful. I'm deeply sad to hear of the passing of Professor Wang. I'm currently working as a chief professor of gastroenteral tract surgery at Post University in Japan. From 2000 to 2003, I had the opportunity to study at the Brown University Research Center, where I had the opportunity to conduct clinical research. During my study abroad, I was able to study not only the medical research, but also the medical research system in the United States under the guidance of Professor Wang. I was able to publish several medical papers, and I was able to live a truly fulfilling study abroad life. After my study abroad, Professor Wang accepted 4 researchers from both universities, including Dr. Iwagami sitting next to him. The attitude towards medical research and the way to treat medical researchers that Professor Wang taught me still lives in my heart and lives as motivation. I really appreciate Professor Wang. Please rest in peace.
So I can't stress enough the connection we've had with these very, very prominent institutions in Japan. Really over the course of probably 30 years. Well, I shouldn't say that, close to 40 years when Dr. Yumiko Fujita came as the first Japanese postdoc. We've just had a continuous relationship with several of the universities there, several of the hospitals there. But rather than me expound upon that, I'd rather call a very dear friend and colleague from many years ago, Dr. Yutaka Sasaki, who was with us at the Mole Hep Lab in Mass General in Charlestown. He will he'll give you the full scope of what the influence that Japanese scholars have had upon the lab.
Thank you, kind introduction, Robson. I'm happy to give a talk for the passing the Professor Jack Wands. I used to work for Professor Jack Wands from 1991 to 1993 in molecular hepatology. Already 30 years passed from that time. So it was very long time ago. First of all, I would like to, on the behalf of all the Japanese fellows in molecular hepatology and liver research centers, I'd like to offer our condolences to the family of Professor Jack Wands. when we got the information from the Rolf-san that Jack-san passed away, we are very surprised and shocked. And soon we will miss him, and also we are recalling the days with we spent Jack-san. That's why I titled today's talk as Fruitful Time with Jack-san. And the san, as you know, that is one of the Japanese honorifics. So Jack-san is our boss, so we call him Jack, call Jack-san, not Jack. We held a party called Boston Club to think of Jack-san on Kobe last week, November 2nd, 2023. And to think, Boston Club has been held annually from 2009 for the friendship of Japanese fellows who worked for Jack-one's lab. We spent a long time to share our memories and think of the days gone by. Because I was supposed to give a talk in this meeting, I collected common impressions about Jack-san from all the participants. Finally, we got the 3 major common impressions for Jack-san. First impression is that he was open-minded and generous. The base of this is that he accepted many Japanese fellows from all over Japan. As you can see this slide, Jack-san had accepted 30 fellows from all over Japan, from Tokyo, from Osaka, and from Nagoya, and from Kyushu Island. Fellows in Green Squares worked for Jack-one's in molecular hepatology, and fellows in Yale Square worked in Liver Research Center. The point is that written screening and the interview by Jack-san were not rigorous. For example, in my case, when I was stuck in research at UCSD, he decided to accept me at the request from my mentor in Japan with little interviewing. And the second point is that once he accepted the first research fellow from Japan, he accepted the successor fellows from the same department, almost no hurdle. As you can see in this slide, for my case, he accepted me. After he accepted me, he accepted 4 successor fellows here in this slide. So we all very grateful that he accepted our Japanese fellows all over Japan. Next, our impression is he is having foresight and wide-ranging research interest. As you can see in this slide, he assigned research theme in a manner consistent with each fellow's original specialty. But some cases are not the case. I will introduce the example regarding Dr. Wakita Takashi. he wanted to continue his original research on HBV in molecular hepatology. But soon after he came to molecular hepatology, one day, Jack came to Wakita's bench and, hey, Takaji is his first name. Why don't you make a research on HCV? Because that HCV was identified just 2 years before he came to molecular hepatology. So he started work on research on HCV and expand his research after he went back to Japan. And finally, he could have published a famous paper regarding sub-replicon systems in Nature Medicine. It's the same case with Dr. Tanaka Shinji, as you can see the video message that he continued to collaborate with Jackson after he came back to Japan, and finally he has published nearly 20 papers. As well as Dr. Tanaka, all the Japanese fellows returned to Japan. They continued and developed their research, leading to significant other advances. Finally, some doctors can be obtained professorships or promoted to the director of research institute in Japan. As you can see in this slide, with regard to molecular hepatology, me and Jiro Fujimoto, and Shinji Tanaka, and Katsutoshi Tokushige were promoted to chairman of each department. And also, Takaji Wakita can be promoted to director National Institute Infectious Disease in Japan, NIID for short. And Dr. Wakita is playing a central role against the fight of COVID-19 in Japan. So he appeared many times on television, making him the very famous person in Japan. And with regard to Liver Research Center, Dr. Eguchi, as you can see the video message, and Dr. Ito can be promoted to professor and chairman of each department. And also Dr. Koga can be promoted to the director of Kurume University Research Center. As you can see in this slide, many Japanese fellows can be promoted. So Jackson was very happy that we are continued to be active and promoted to higher position. And final impression is he loves Japan and hopefully Japanese fellows. I don't know exact times of his visit to Japan, but we are sure that Jackson loves Japan. As you can see in this slide, he often carried his own golf bag to Japan and played golf with us in Kumamoto with us, with me, and in Osaka with Jiro and Takaji. And also he loved Japanese dishes and enjoyed with us. And I don't have a picture, but I remember well that when he was visited to some meeting in Kyoto, we took him after dinner to the karaoke box and sung a song titled Massachusetts. You remember? It's a hit chart from Bee Gees in 1967. It was very, very nice memory for us. And after I moved to Kumamoto University, I invited him twice once in 2005 and once in 2015. This is a picture taken in front of Kumamoto Castle. When I asked him to go up to the castle tower, but he said, no, I have a fear of heights. So that's why we cannot take a picture in the castle tower. And upper panel showing his invited lecture in a 51st annual meeting of Japan Society of Hepatology, JSH. And during that meeting, we held a Boston Club in Kumamoto, and Jackson enjoyed the meeting. This is the final slide of my talk, and we will continue to devote ourselves to research, following his will of research. Thank you for Jackson, and we will never forget the fruitful time we spent with you. Thank you for your attention.
The next video from President Dr. Mian Chi Hung.
Colleagues of Dr. Jack Wentz and Lee Hung speaking to you from Canada. Jack and I and others have been working with Build Corporation in the investment between Columbia University and China Medical University in Taiwan. I was shocked and heartbroken when I learned from Dr. Xiao Trinidad that Jack Wentz had passed away. Jack's effort over many years has significantly improved the survival rate for liver cancer patients. We know that because of his contribution, the cure for liver cancer is coming. Without Jack's guidance, leadership, and support, it will be more difficult to achieve that goal. But we will continue to work hard and try to make that dream a reality. Jack has done so much for victims of the disease, and so much for all of us who have a common goal to combat cancer. You will be remembered and deeply missed by many colleagues in the medical and scientific community, and by his family and friends. Jack, rest in peace.
And to close off, I hope everyone's holding up well. Thank you all. In addition, Jack was very good with sort of grants, I have to say, over the course of the many years that we were there together. As a matter of fact, I think one of the big attracting factors in terms of him being recruited to Brown was at the time he had 4 R01s from the NIH, which is almost never done. He had, at the time, he had a DARPA grant with MIT. There were 2 sponsored research agreements. And, so in addition to the rather generous seed money that he was bringing all that, which meant the investment they were making in terms of providing money was going to be paid off by all those indirect costs that the government was going to be paying. But over the course of the time that I've known him, he would just come up and all of a sudden say, like, yeah, we're getting a sponsored research agreement with this company. I'm like, who? And there's been many, some that I don't think exist anymore. Some of them have gone on to become very big things. They mentioned Centocor that ultimately got bought by Johnson & Johnson. We had one called Molecular Geriatrics that didn't make it. but he's had a lot of association with people who are in the industry, and I'm pleased to have Russell Garlick here, who is working with LGC Diagnostics, formerly SarahCare, who's continued to sort of believe in the work that Jack was doing, and also has known him for many, many years, and like to offer his remembrances and association with Jack Russell.
Well, thank you, Rolf. And first thing in the video, you didn't have your safety glasses on and you were working with radioactivity. Thank you for organizing this, Don, of course, too. And thank you to the Wands family. I love the analogy with crystallization because for me, this is a chance to crystallize a relationship. And it's wonderful. It's absolutely wonderful. I hope you sense that from all of us who've come here today. So yeah, Russell Garlick, I'm the CSO for LGC Scientific, but actually I want to start much earlier than that. When I was like a group leader, working for a company, NEN Life Sciences, we basically made all those radioactive ligands that you were using in immunoassays, okay? And laboratory over in Albany Street in the South End, okay? So this is not the beautiful Mass General campus. I can remember my colleague and myself, Carl Adler, going to Mass General, to this brand new facility. It was a beautiful sunny day like this, sitting down with Jack Wands, and the sun was just beaming in. And he was so enthusiastic. I didn't know all of his background. We just knew we had to improve the technology we were working on a molecule you actually saw it introduced earlier today, hepatitis B surface antigen. Okay, this funky little molecule that circulates in blood, and we wanted to develop a more sensitive method for it. Now, Jack had all the monoclonal antibodies. He had well published in the area, and he actually answered my call. He said, let's do it together. So Carl and I, we worked on something called the enzyme-linked oligonucleotide sorbent assay, ALOSIA. Everybody knows what an ELISA is. This is an ALOSIA. And it was kind of the formative days of immuno-PCR, right? Well, anyway, 2 or 3 years later, it all worked. We got it published. I think I put a copy of it up there. And as I was reading it, I said to myself, if we went back and I could see Jack today, I'd say, Jack, we said the sensitivity, we got it down to a 0.5 picogram per mil, just a 0.5 picogram. But we didn't say, was it per mil? Was it 10 mils? Was it 0.1 mils? I said, I'd go back and correct that. So anyway, very successful. We got it published. Now, my career went in different directions. I was part of a company. I ended up being, head of R&D for NEN Life Sciences. We were sold to PerkinElmer. I went down another path of starting a company and selling the company with PureTech Ventures. And then it came to 2012, okay? And I joined a company with a blank sheet of paper on getting the company turned around and growing into something called clinical genomics with next generation sequencing. Okay, so it's a blank piece of paper. And so my first project as an R&D head for the new company is, again, this funky little molecule, HBsAg. Now, I hope nobody's from the FDA here, but we had a stability problem. Okay. We developed these standards just 2-3 times above the sensitivity of the blood screening assays. So blood screening assays here, we'll develop a standard here. And if it starts to lose potency, it falls out of specs. Okay, technical problem. Who did I work with on HBsAg? Jack Wands. Okay. Now, remember, I've done many different things. I didn't even know where he was. I go to Mass General. He's not there. I track him down in Rhode Island at the Liver Research Center, and Jack answers the call. Isn't that amazing? To me, it was amazing, So I go down and I see Jack, smaller office, not as much sun, but he was beaming with interest in what we were trying to do. Not about what we did yesterday, but what we were trying to do. Now, and I'll give you the executive short summary of it. So we're trying to learn how to develop these standards for cancer, complex cancers, solid tumors, and brainstorming with Jack. And to me, that was the most valuable thing he brought, not only to me, but the scientists I would bring up to the Liver Research Center to sit around the table and talk about what we're trying to do and how we get there. And Jack would help us maneuver. He would have open discussions. And we went down a number of different paths, and you won't see them published. Okay, but I can give you the insight and how important this has been into the growth of the company and the success for us supporting cancer patient management. We first started down the path of patient-derived xenografts, okay, to replace human tumors, because you can't sell human tumors around the world as standards. We were trying to make standards in this area. So we went down the path of patient-derived xenografts, and we had this idea that we could use those to replace human tissue. It worked beautifully, except there was too much stroma from the mouse in the sample, so it didn't pan out commercially, but we learned so much about, solid tumor sequencing from those experiments. And then interestingly, I kept saying, Jack, this is where we're going to go. This is where we're going to go. We need some help. And it was into liquid biopsy. And of course, Jack had the clinical vision, he had the technology, and he had the connections. And we started collecting circulating cell-free tubes of blood using specialized approaches that we could then replicate those cancer mutations in the blood via some methods we were developing. So we couldn't do any of this work without the first step, which was conversations and collaborations with Jack Wantz. And interestingly, the first products that we launched was not in cancer, but was in circulating cell-free for non-invasive prenatal testing. And we've been the first provider of those standards into that marketplace through some collaborations with Jack Wantz. Then we moved into real liquid biopsy, looking at circulating tumor DNA, again, through collaborations in good scientific discourse. And I'll never forget, the scientists I would bring to these meetings with Jack, they'd only be for an hour and a half, but would all come out of there, thinking about all different ways and all different approaches to do our work back at our own laboratory. Very, very successful. And I said, I've had the pleasure of collaborating with scientists around the world my whole career. And he was a true spirited collaborator. It was always a two-way street. And as I think about, as I try to work with others, I'm always keeping that model in mind. Listen first, and then think about the direction you want to take teams. So that was great. And I kind of ended my title with friend. I don't know when a person becomes your friend, okay? But I know Jack is my friend, and it happened somewhere along the line in my second stint with Jack. I think perhaps the time when even just answering the call when I had a clean piece of paper, I didn't know what to do, okay? To sit down and talk about it, a friend will do that. I needed to have a keynote presentation at an American Association of Cancer Research meeting. We were bringing in people who were expert in next generation sequencing. Dennis Lowe from Hong Kong University, for example, and many others. And I needed to have a draw who would be seen as that type of person. Before I could ask Jack to come to Chicago just to give this presentation, he had already said yes, okay? And then, most recently is that we've moved into, this area of epigenetics, and he always said yes. So there was some point on the line here where he went from a world-renowned scientist to one of my most productive and favorite collaborators to a true friend. So I just like to close by saying, we will miss him. The field will certainly miss him. My team at LGC Seracare, I know will miss him, and I'll miss him personally. So thank you very much.
Let's have some lunch. That exhausting session. No, great. Thank you to all the speakers. It was a great presentations all around. I think we got a true understanding of the impact that Jack has had on so many people. Take a break now. Be back in an hour, and then the afternoon session is geared towards the mentorship of the people who have worked with him and continued on and are actually quite productive and successful now. So relax.
And I was also so we have access to a lot of packages. That I'm not sure, but if you have otherwise, we can just follow get something
Yeah, well, right now, it's very fine, but yeah, it is, you know, so Steve did more accounting work. This is more, you know, yeah, it's fun going through that.
Yeah, we live very much in the world. We have 7 months.
Yeah.
So, yeah,
Yes, it's very good. Right. So, like, yeah.
It's like towards
That's like for the promotion.
It's so honest. Yeah.
Yeah.
Yeah, I know about the
And they start to I'm going to all right. And then my daughter, yeah. Yeah, my daughter is floating around. So she's
I think
You did this. Of course you did.
Good afternoon. I hope everybody enjoyed lunch. Okay, now that you all had something to eat, please don't fall asleep. As Dr. Wands was was very someone who had a lot of people that he mentored, that he taught, and over the course of the many years, some of them, like you've seen already here, have from Braun have gone on to achieve significant success in their various fields, and many of them started, I won't say small, but started as students or fellows at the Liver Research Center, and are now quite well established in the fields, and particularly the fields of research that began at the Liver Research Center. And so I've invited several of them to come up and give us a refresher of their the type of work that they've done and where they've gone with it. But before we're going to start off, he also had we had a relationship with the third military hospital in Beijing, China. And one of the research fellows at the time, Dr. Kay Lee, was very close to Jack in terms of establishing a relationship with an institution in China. So we have a video from him.
For those who don't, my name is currently director of Canada Health Medicine at the Xi'an Hospital of Xi'an University. Previously, I was a physician in the 302 hospital during that time there. I got the opportunity to work with Jack. I did my postdoctoral work at Brown University Liver Research Center from 2003 to 2004. When Jack was the director of the gastroenterology department at the Golden Island Hospital, the professor of the Brown University Liver Research Center. During my postdoctoral work, Jack was very nice to me. I remember that in 2004, the director of my work unit asked me to go back to China earlier for the short time. Jack said that if you are going to stay in the US, you can help me with the visa process. And I was very touched by him at the time. After I returned to China, I established a very good relationship with Jack, who was not only my father, also became my friend. We have sent out fellows to each other 3 times to visit each other's units, and Jack said that 3 of the hospitals is their overseas rotation base. In 2016, I also went to the gastroenterology department of Oregon Hospital to observe a PI pathological rounds, and I was very surprised to see that the doctors in Jack's department were able to make a correct diagnosis based on the pathological signs, along with knowing the history of the disease at all. Professor Jack is very warm and hospitable. He treated the people assisted to the Able Research Center very well. He did not only provide conditions for experimental research, but also provided the opportunity to observe in the clinic. So that our young doctors get the opportunity to grow rapidly. Dr. Yan Tao, Xi Chengchen, and Wang Yinggang, who rotated there, are now directors, all deputy directors of different medical departments. We would all like to thank Jack again for his training. He taught me some very interesting things in our daily communication. For example, he once said, Ken, if you have an important speech or interview tomorrow, what should you do if you can't sleep at night? I said, I will take some sleeping pills, but he said, you can take a propranolol, which is what he did when he was young. Since then, I've taken half of a tablet of propranolol to overcome my chronic anxiety whenever something major interferes with my sleep. As he said, it worked again and again. During the beginning of COVID-19, we did not stop contact. I heard the Jack's department staff didn't have N95 mask. A few of us who rotated there donated some masks, but due to the difficulty of transportation, the mail arrived 1 to 2 months later. I don't know if it really happened, but Jack expressed his gratitude. Jack had countless achievements. He had an admirable academic tenure, hundreds of academic patents, publications, and anti-tumor small molecular drug on the development. He was an internationally recognized medical scientist. As a former student of peace, I was most impressed by his unlimited passion for work. He worked with love, rigor, and most importantly, with sincerity. He was even hard working with the blue light eye must have helped to overcome the jet lag after long distance travels. He was always willing to do his best to help both patients and fellows. When I heard the news of Professor Jack's passing, I was afraid of love for work. I always thought that he was in a very good health when he was on a visit to China. Even in the hotel at the time, he still went to exercise like weekdays. I would have planned to go to the United States to see him this year. However, I got a U.S. visa interview in December of this year. It is pity. The earliest time I would have been in the United States is January next year. I'm truly saddened by the news. I can still hear his voice and smile like it was yesterday. I will miss the days spent with him in the lab for the meetings and experiments. and the days Professor Brockman and Senator Cisco to attend the annual meeting of the American Association for the Study of the Liver Disease. And we are surely miss the days when he came to visit us in China. Rest in peace, Jack.
Thank you. So Vivian Ortiz is she started as I think a Brown student. Yeah, she was a undergraduate at Brown. She started at the laboratory, went on to medical school in Chattanooga. No, just kidding. She went to Metairie in Nashville, and I always, every time I mentioned it to her, I always chose some other city in Tennessee. Weren't you in Knoxville or something like that? And this running joke that we're going. And now that she's in Jefferson City, Missouri, no, St. Louis. She's gone on to become a specialist in the diagnosis and of liver disease, and also determining whether or not surgery is appropriate and stuff like that. She does that at Washington University Medical Center in St. Louis. And I've asked her, since I know that Jack was particularly proud of her and the accomplishments that she made, and I thought she would be a fitting person to give a talk.
Does that have a laser pointer? Where is it?
It just doesn't go on the screen.
Yeah, it's up on the wall.
Yes, but it doesn't go on the screen. Yeah.
You can put your finger on it. Yeah.
I could. So it's an honor for me to speak, and it is sort of my due diligence to try to honor him as much as I can. And for me, I thought that the perfect topic would be to title it Vaccine and Prophylaxis for Liver Maladies and Life Beyond, because I think he not only impacted the career that I decided to take on, but he also impacted the way I approach life in general as well. So it all started when I was an undergraduate student at Brown. At that time, I had joined a physical chemistry lab where we were trying to coat gold nanoparticles so that make them functional so that they can bind to one of the antibodies that he had made. And then the idea would be that if, for example, we would use this coated antibody, gold conjugated antibody, deliver it to a tissue of interest, then we can use X-ray imaging that will show us exactly where the tumor is by the scattering technique that we were also using in the lab. And so we found that when we specifically coated this gold nanoparticle with pegylated material, we were able to get successful binding to the antibody. And then you can see here that by immunofluorescence as well, you can also see that that the binding does work, that there is labeling to the specific cells that are related to liver cancer. And when we tested it in vivo in mice, we saw that there was definitely much higher signal in the mice that had been treated or that had been given this gold nanoparticle. And you can see in the image that there is a location that it marks the exact location of where the tumor is. So this actually went on to be the topic of my thesis as an undergraduate. And then also we ended up actually getting a patent out of this just from the chemistry of the gold nanoparticle conjugation technique. But then as I wanted to be a physician and I wanted to do something a little bit more biology related, I went on then to do some immunology. And the way I started was helping the work that Di-Chong Fan now, he's a professor at the NIH, and we're trying to help his work in looking at the inhibition of dendritic cell function by alcohol. And we went on to find that it does cause a decrease in the function of the T cells by decreasing the cytokines and more of their cytotoxic response by a reduction in IL-2. Then I worked with, I was assigned to work with a PhD student at the time. His name is Ahmed. Eken, who's also now a associate professor in Turkey. And with him, we try to unveil the mechanism of how this was done. And we found that this was done by reducing antigen presentation by dendritic cells. And believe it or not, this is Eken. I drove him crazy, but we did really good work in that time. Once he left to go and do a postdoc in Turkey, I was then left on my own. And then Dr. Wands had the greatest idea of including me in a dendritic cell-based vaccine project. And the way that we were approaching it was sort of helping train the dendritic cells to recognize a particular protein of a given illness, and then give it to a mouse and then see how they respond. And we were using, in this case, hepatitis C core protein, but we were not interested in sort of curing the disease at this time. We were more interested in seeing how the immune response is different from mice that were treated with alcohol, from those who were treated with regular diet, and see if there was a difference in the activation of the T cell, cytotoxic T cell response. And so there was the reduction in the activation of T cells, and then also the cytokines that are associated with the function of it. But I think for me, the most impactful project was one, and actually this one was my own project with him. All of this have been published, but I think the most impactful project for me and for my career was one that I got to participate in to help Takahiro Noda, a professor now in Osaka. And we were doing a dendritic cell-based vaccine for cholangiocarcinoma. Again, using the same sort of concept, you sort of train the dendritic cells to recognize the cholangiocarcinoma. And then once you give it to the rats, there was a significant reduction in tumor size. And again, show that there is a sort of a ramping up of the T cell activity in the mouse compared to the ones who didn't have the specific antibody, who were not treated with the treatment, with the vaccine. So this was impactful for me because this is sort of one that led me to become very interested in the field of cholangiocarcinoma and hepato-oncology in general. And it is sort of the theme that I've sort of carried through since then. And it is what I want to focus on going forward. But I think one of the things that we had at the Liver Center were really the social events that I think, made it all feel like a family. These are some of the pictures that we have from, or that I'm showing from the dinner parties that we would have during the liver meetings. And it was the times where I met, some of you who are in this room. And whenever I go into the liver meetings and I see you in other countries, it's a great pleasure to really talk and sort of tell stories about how we're tied back to the Dr. Wands' experience. Then Christmas party, we would always have this Christmas parties were always a blast. And Rolf would always have us sing the Silent Night in different languages. And of course, for me, like Spanish was no longer challenging. So then I had to go and try to do it in Japanese. And so I would always try to do it in as many languages as I could. But that was sort of what was fun about the Liver Center. It was a great community. And it was so international that I think that's that drove me to want to learn more about people, more about their culture, and see where they come from. We had this famous cake hour at 4 o'clock every day. And believe it or not, I always had the biggest pieces. And Rolf would look at me and say, "How are you going to eat that?" And then Donna would say to me, "How do you still thin? I don't understand." So there, and then the other thing to mention with that is that Rolf would not only take pictures just to document, but he would also put it on this website, cakehour.com, and he would keep a blog so that everybody would know that you're eating humongous pieces of cake. So yeah, it was very yummy. 4 o'clock was a favorite time of mine. And then we also had really other fun times. I call it the arts and athletics of the LRC because Ralph extremely talented in many domains. He yearly is involved in the school play, and he's just so good at it. So we were trying to go to the play and see his work. And that time we got to see the Phantom of the Opera, and it was really, really good. But he would also do a yearly ski trip. So there's a picture of us. I think that day I think I went down the hill with Rolf, and I was like, I did the biggest mistake possible because we ended up going to double diamonds, and I was like, I don't know how I'm surviving. But there I was, I survived at the end for the picture. And, but you know, despite the many fun you would think, you probably didn't do work, but no, we were actually very productive. We got a good amount of publications, and we definitely made a presence at delivery meetings by presenting our work. So of course we were having so much fun that the day that where I had my last day at the LRC, I was like so emotional. And I remember crying so much. Donna was like encouraging me. She's like, it's okay, you will like country music. I was so scared of like moving to the South. And I thought like the world was gonna end because I was moving to the South. But it, you know, and sort of, you know, they did a farewell, and to me, this is just, it's still such a good part of my life and a good memory that I keep with me. But it didn't really end there because, you know, as much as biology and immunology I learned there, you know, sort of these vaccines that I was working on, it was sort of like a vaccine for me as well. And it really like helped set the stage for all the things that I was doing after. So I went on to, well, actually it doesn't work anymore. The pointer. Sorry. Okay, there we go. So then I went on to medical school, did my residency at Yale, then gastro at Penn, ended up doing my fellowship at Mayo. And all of this has led me to where I'm at now, starting my position as assistant professor at WashU in transplant hepatology. So I think and then throughout this whole time, he had been mentoring me, and anytime I had any trouble, he was always available to pick up the phone and listen to what I had to say. Some of the other prophylaxis that I think I learned from the lab are shown here. You know, it wasn't only in the career that I did, but it was also, again, the way that I approach life that I think he really inspired. So when I joined the liver center, I had been injured for a while and I couldn't really run. Maybe I would run like a day and then I would be like in pain afterwards. But after I joined the LRC, I got health insurance. And so, and so then there was also the law of the preconceived, what's it called? The precondition or the preconceived condition that it was now being covered. So I was able to go to a doctor. They were able to diagnose me, and then I was able to go to physical therapy and then and then get back to running. So the bottom left is my first half marathon that I did in Newport, Rhode Island. I actually surprisingly was, as you see in the picture, like surprised of how well I did. I then went on to get qualifying times, and then I ran Chicago, which is the bottom middle. And then eventually, and then with that race, actually qualified to Boston. So I was so proud and I was so happy that I made it a point to come back to the LRC. At the time, I had already left. And then, you know, share the moment with Dr. Wans. I was wearing the Boston jacket. And since then, it's been, you know, I kept running since then. He, you know, every time I had a tough time, he would always ask me, "Are you running?" Because he knew that it was, he knew that it was, it was my method to cope. And he knew I loved it. During the LRC, I also got to travel. So it was my first international trip on my own. And the places I chose, again, were inspired by the LRC. So the one on the left is in Turkey, is in the Hagia Sophia. And this is a place that we would always talk about a lot. And obviously Ahmet is also from Turkey. So I was inspired to go to Turkey to, get to like know where he's coming from, learn about their religion, and see all the sites that Dr. Wans would always talk about. And then the year after, I went to Israel. And that was also really, really good experience. Another place that Dr. Wans really loved. And we both found it fascinating because we always thought that it was just so, hold on, let me take a break. Anyway, it's a place where there's a lot of conflict. Clearly today is a big example of it. But somehow, people seem to coexist. Obviously now it's questionable. But just for hundreds of years, people have been fighting over this one territory. And so we always found that very interesting and we would have conversations about it. So I clearly wanted to go. And then since then, my travel bug continued and I have made it a point to travel throughout the world. Many places are not pictured. But again, a lot of it has been inspired by my time there. And Glühwein has been another. So every December, we would have a day where we would have Glühwein with Rolf. Rolf started this tradition. And funny enough, now every winter, I find myself trying to find a Christmas market where there is Glühwein. And these is actually, these are Poland and then Hungary, some of the Christmas markets in Europe that I was able to also be lucky enough to taste. They all have their different flavors, they're different liquors, but they're all really amazing. And then, the biggest thing has been friendships that I definitely built in the lab. Zoli being one of them. He's the one who started bridging sort of this gold nanoparticle project. He was at the Liver Center while I was at Brown. So he was sort of the bridge in the collaboration. We would always joke with him because he would, his name is Zoltan. So he would always be around the ladies. So there's a picture on the top left. And we got to, tour San Francisco with him. And, since then we've stayed friends. I was able to meet his wife at the bottom left. Now they have kids and hopefully you'll see him tonight. Ahmet, who I told you about, I drove him crazy, but believe it or not, we became good friends. So when I was able to go back to Turkey to visit, I was able to meet his family, have dinner with them. And actually, I'm really excited that he's coming to Boston to do some sort of baccalaureate in a way for 2 years. So I'm going to get to see him soon again. Yoshi, he's somebody who, he was working so hard on Saturdays and Sundays. You see, I had just run a half marathon and this guy was still pipetting in the lab after my marathon. So I had to come and say, like, what are you doing? But he's another person who, again, we've kept in touch. And so when I was able to go to Osaka, we met and then we toured around. He had me eat all kinds of fish there. That is another person that we got to really interact. Also, I got to see him when I was in Tokyo because we would love to talk about hockey and food. And Take, this last picture, I think, is from I think like 2 or 3 years ago when he was able to come to the ASLD. But again, when I went to Japan, I was able to have dinner with his family. So that was really nice. Of course, Rolf. Every time I come to the LRC, I always try to stop by, say, "Hey, Rolf, how you doing? Did you get a new cat?" have Steve, right? So I get to like always interact with him. And, you know, I think the biggest thing that Jack did for me was the mentorship, guidance throughout. You know, I say that he knew me better than I know myself in many times. So he knew exactly what to say anytime that I needed his help. And like I said, you know, even after I left the LRC, he still was very engaging and he was very available whenever I needed. So I made it a point to stay in touch. And regardless of where I was in the country, I would always try to come to Rhode Island, find an excuse, and come by to the LRC and meet him. And I was sharing earlier how the day that he passed, I was actually giving a talk for the American Gastroenterology Association about mentorship. And I was actually talking about him and how he was, you know, the perfect mentor for me. And then, you know, an hour later, I get a phone call from Rolf that he had passed. So anyway, I'll be forever thankful. So thank you.
Thank you, Vivian. Keep coming by. There's always cake. And we'll always have a big piece for you. But we have a video here from the Chief Chair, Professor Cheng Wao Lu. And now another mentee who's gone on to make his mark in liver disease. Kostika. Kostak Alman, he was here as a from a research associate postdoctoral fellowship at the Liver Research Center, and went on to ultimately be, well, I think now you're in New York, just short north of New York. So like prior to that, he was at Rush University, also working in transplant hepatology, and is also was another one that Dr. Wands was particularly proud of in terms of his accomplishments and how far he's proceeded. So please.
Thank you so much. So, like many other people from here, my career was also marked by Jack. And actually it took me, usually I'm pretty good in taking decisions, you know, but I had to ruminate regarding the title that I'm going to choose. So, because from science perspective, you know, my meeting with Jack basically opened my field of expertise, that is dendritic cell biology. But, and basically I didn't know exactly what kind of title I had to choose. So let's tell you a little about me. So the figure is a little misleading here. I spent the period of time between 2003 and 2006 at Liver Research Center, and I was on a training grant. I was a resident in Iowa in internal medicine, and I had to apply in 2002 for GI fellowship, and I didn't get a position. So I reapplied again in 2003, and basically it was supposed to have a gap of 1 year. And I had some backup plans in my mind, but basically Jack offered me a position on the training grant without knowing me, only because he told a little later to Scott Freeman that it was my next mentor, that actually I had a fire in the belly. To be honest, I didn't know what is that. I didn't grasp, because at that time also I was not speaking very well English, because all my English is from South Park and Married with Children. So this is the truth. So, and even now I'm speaking, sometimes my sentences are from movies or TV shows, cheap TV shows. So the bottom line is, like, while I was at Liver Research Center, 3 things happened with me. So I developed the skills in basic research. I started to develop my niche of expertise, and probably I got my first step how to write a grant or to write an application for as an early investigator. And it was some kind of crazy, at least in my mind. Do you know? My first day at Liver Research Center, it was like the black sheep between all these people that they are very smart. I couldn't understand anything from what Shuping is doing, because I'm not a virologist. Yes, so really all these things with the HBV, like I know the clinical part, but I didn't understand the basic stuff. I was in the same lab with Mira, that later I started working with her. So I didn't understand anything from signal transduction, what she is doing there. On the other lab, it was Suzanne that it was still very difficult for me to understand what the neurons are doing there. So I was very, very confused. So that was basically my position at Liver Research Center. So Jack offers me 2 projects when I went there. So he asked me, what do you want to do? You know? So I was like, I have 2 projects that I can offer. One, you guys, you heard about these AF20 antibodies and monoclonal antibodies. Like, you can try to see exactly if this monoclonal antibody, has any effect on HCC. And although I don't know what the heck it's doing, we can see if there is any effect, therapeutical effect. And the second thing, you can start to work on the dendritic cells. There are these cool cells that are discovered like 20 years ago by Ralph Steinman, funny enough. So I'm originally from Romania. So Ralph discovered the dendritic cells because another Romanian told him to take a look on the cells. That it was so the guy who discovered the electron microscopy, actually it was at Rockefeller, it's Emil Palade, and actually told him, take a look on the cells, and actually in this way he discovered the dendritic cells. So I said, okay, I'm going to start working. So don't look on the science. The science is not very important. I'm going to tell you only the stories about this. So I had to start learning stuff, So I started actually with immunofluorescence. So all these like 6 slides took me forever. I don't know, like 3-4 months, because I didn't understand anything actually at the beginning. Do you know what immunofluorescence is? I was using all the time the wrong mounting solution until Rolf came and actually told me, you're not, this is for the paraffin embedded tissue. Do you know? It's like everything was crystallizing and everything was fluorescent until I got it. After that, Suzanne from the other side of the wall taught me something. Take a look on this actually to see where is going this antibody. So I tried to do some immunofluorescence actually to see where this antibody is going inside the cell. So it was very cool for me learning new stuff, So, and after that, Rolf taught me a little, how to put tumors in the mice and to monitor exactly if you inject the antibody, there is impact on the growth. So make the story short, actually 1 year later, actually we generated an abstract, for ASLD. So it was my first presentation at ASLD. So I think if I go back, actually it was only 1 year and a little to generate all this data, and you start from scratch, which I think going back, because I'm in a higher position now, actually Jack was very good in creating the environment, foster the environment to develop from scratch. So I don't know how he knew that I'm good enough I'm good on doing this kind of stuff, because again, actually I did some stuff with my hands. I didn't start really zero from scratch, but basically there are completely different techniques, So at the same time, I start to work with other people in the lab, and probably, as I said, fostering the collaboration in a group. It's an art. Not everyone can do that because you have to give the freedom to the people to do it, but at the same time to be also productive. So it's a very tricky balance. So I start to work actually with Stefan Gehring, that it was at the time in the lab, and actually Nori Kujoshica from Japan, on this dendritic cell stuff. I thought it's very cool, yeah? So the cells were discovered like 20 years before I was in the lab, so in 1970 something, And one of the things that I learned, what Jack told me, don't be afraid, of unknown, because actually, okay, the first project, he was working all the time on these monoclonal antibodies, yeah? But actually, this is a area that nobody knew too much. So I think actually, if you want to make some progress, if you look on things that actually other people didn't do too much. So from these two projects, I thought probably for me, the one that's actually maybe I should invest more in this kind of stuff. And again, the second thing that actually it was a lesson for me, don't be a loner, don't be secretive. That doesn't work in science. Even now, I know that the people are afraid, I'm going to be, actually, someone is going to steal my idea. I think talk with the people around, because this is science. You're not going to be scooped out. Or if your idea is scooped out, that means maybe it was too evident to something that was very easy it was not valuable in my opinion. So as I said, there are like these cells that are very cool, named dendritic cells. They are like very important actually to stimulate your tissue defense. And they have this ability to migrate, So normally there are two types of major innate immune cells. One are the macrophages that they stay in the tissue. They are the soldier, they fight with everything, But this one are very smart. They're more like James Bond, but the James Bond that is dying, basically. Is there into the lymph nodes, say, come here, I need more help. So basically, these are the dendritic cells, if I have to ask. So one of the things that I learned, again, from Jack, and actually, I'm very frequent, actually. I'm taking on this skill very frequently with the people that I work with. It's actually, if I have someone that I want to invest, I'm going to invest to develop their skill independent of the price. And the truth is that the price for my skill to develop flow cytometry, it was actually $4,000, which actually in 2004, they're a lot of money. So basically, Jack sent me and Stefan to BD Bioscience here in Massachusetts. I don't know exactly which town, And for $4,000 each, basically, we got the training, to start from scratch, And as a matter of fact, actually, we got the diplomas. I still have it at home that actually I can go to work in a lab, actually in a clinical lab, and to be actually a tech lab, to get a job there, and to get the amount of money, only from that job and doing flow cytometry in the clinical lab, because you get professional licensing to do that. So basically, I put there a plot, because you're using actually different fluorochromes, colors, so someone made a fun from me that there are not enough colors on the lasers for my cells to be characterized. Like all the time I want one more. And actually, this ended up being my expertise field in the way that I'm doing assessment of the immune system. So, so basically, what I learned basically, I had to learn actually how to assess the immune crosstalk. You guys, you heard about actually, I have to learn actually how the interaction between the dendritic cells and T cells is chemical defense system happens in the body. And one thing that I didn't learn how to do it, I didn't learn how to keep it simple, never. This is one of the, because all the time, Jack told me, try to keep it simple. I never was able. And actually, it's funny enough because this is one of the experiments. So each bar means a different group. It doesn't matter what each bar, the specifics of each bar, but you can see there are multiple groups there. So this experiment happens normally over 48 hours. So me and Stefan, we stay in the lab for 48 hours and go only from time to time to eat. So when I recall that, and I have to repeat it for 2, 3, I think this was repeated for 3 times. So basically we had 3 weekends. I remember that we stay in the lab and each of us were like leaving for 1 hour and eating something like that and come back. And it's funny enough because Ralph Steinman came actually after first time we repeated the experiment to give a talk at Brown. And he came in the lab actually to meet with Gregory. And I showed him this data and he said, how long time is it take you to do this? So, and he said, keep it simple. I never was able to learn how to do it, but the bottom line is like this, because there are so many controls, the experiment was so well validated that actually when it up actually, and this is my paper that is the one of the most cited, that basically we show, it was the first time when it was shown that basically if you, mice that is fed exposed to chronic alcohol, actually if you basically change the dendritic cells, you change the fate of the immune response, the way that reacts actually the mouse to different things that you put in the body of this mouse. So I think it was, and it's very well these days, these things is very well validated, and everyone knows that actually it's one of the mechanisms by how someone who is drinking a lot is predisposed to the risk of infection. And or why, for example, if you get a vaccination to someone that actually is drinking, they're not going to respond the same. So it's when I went back yesterday and I look on back on the data, it's not only that. Keep in mind that we were doing in this experiment, we're doing actually DNA-based immunization. And actually, we had a long discussion. We have all this vaccine regarding against the COVID. We had a long discussion what we were going to choose. We were going to use DNA, RNA. It was. I don't have any more what kind of plasmid are you using. So I think it was so visionary. Because you're doing all this stuff so early, before all these things actually they got validated in our normal life. So, so from that point, basically, the field of dendritic cells for me got very close to my soul. So, I think I went in my 3rd year on the clinical side, and probably 6 months before I finished my fellowship, Jack asked me, "What do you want to do?" So again, I didn't have any plans, and I said, I want to do transplant hepatology. This is my, actually, I was part of the team that did first transplant of kidney and actually liver in Romania. So really it's for me, I want to go back and do that stuff. And actually, I was surprised. Jack put the hand on the phone and called Scott Friedman at Sinai. And he asked him, do we have a position for this guy? So it was normally, again, the interviews for a position as a transplant hepatology fellow, it's actually 1.5 years in advance. Yeah, so this was 8 months, something before actually starting a year. So it was something crazy, And Scott said, I have a position, but he needs to pay his own entry, like his own salary, like he needs to find the funding. And actually, I didn't put anything regarding that, but actually I wrote a grant. And I show actually the grant actually initially to Jack, grant got funded, and I bought in my position at Mount Sinai as a transplant hepatology fellow. So, and from there, it's more or less, it's like, it's a lot of work, but actually that's my path that put me actually in the field, because basically I start actually to be involved in all this dilemma. What is the dendritic cells? What is a macrophage? So anyway, so again, these are only the pictures, that show some work related with that. The way that actually these dendritic cells, they are different than macrophages because they're making a lot of stuff that they help basically to digest the scar in the liver. And basically this FLT3 ligand, basically it's the first actually growth factor that actually promote the production of the dendritic cells. We used to do it at Liver Research Center actually by injecting the mice with these things in the tail of the mice. That's very hard, So basically what I show that actually these dendritic cells, they can digest the matrix, they can digest the scar in the liver, basically. And the same thing, if you transfer these dendritic cells in the liver, in the mice, that they have scar in the liver, actually you can digest the matrix. Do you know that it's the scar in the liver? And actually this gave me first, like 5 years later after I started with, after I left the Liver Research Center, basically my first plenary presentation at the ASLD, some kind of scary, gave me the Liver Scholar Award and my KOA. So the way that I started basically my career as a physician scientist. So later during the years, like 4 or 5 years later, basically I start looking into the diversity of dendritic cells. When we started initially, we didn't know too much that there are two types of dendritic cells. One, they look like the initial dendritic cell, the other that looks more like a lymphocyte, like a smaller round cells. And basically, I got R01 funded by NIH 5 years ago to study this population of the dendritic cells that apparently they are making a lot of noise in the body, and seems to be basically the basis for what actually, for example, females are more sensitive to alcohol than men, and why you have so much inflammation in the body in the moment you are drinking the alcohol. So this is my last slide. This is a picture that actually there are 3 people that actually helped me quite a lot in my career. So Jack opened my path for something that I didn't know, that I have Scott, my mentor from Sinai, and Stefan Gehring from Germany, that actually we spend many nights in the lab. So thank you.
Thank you, Kostika. You did good. And a video from President Professor Dr. Lianshan Liu is next.
Of the first affiliate hospital of the University of Fest and so on. I'm shocked to learn that Professor Jens scientific methods in this study to express my deep condolence to Professor Vance for service. Professor Vance is a good friend of mine and a good friend of many cancer. He worked hard and continued to strive. He loved life and was full of sunshine. He has helpful and selfless. He devoted his life to the study of liver disease and regularly many patients. His collaboration with science partners has led to the development of liver disease research. What you need, we lose a good partner. Patients lose a good doctor, and students lose a good man. Professor Vance, you will always be peace. Professor Vance, rise in peace.
Now, next talk is from someone who started at Brown as a gastroenterological fellow, I believe, and then went on to become a physician at Lifespan at the women's. You're going to clarify it, yeah, stuff like that. Again, Colleen Kelly, someone that Jack deeply respected as a physician scientist, also is here, and she's going to talk about some rather interesting treatments.
Thank you very much for inviting me, Ralph, and to Dr. Bond's family. It's a real honor to be here. I first met Jack in the elevator on my way up to my interview at the Liver Research Center, and I had done my homework ahead of time going into the interview, like to know, what the different people look like. So I recognized him in the elevator, and he then offered me the position 2 days later. And I finished my fellowship in 2006 and then stayed on for about 17 years as faculty at Brown and a member of his faculty. And there's going to be very little liver in this